Okay, hello class. You're welcome to today's mathematics class. And today we'll be talking about binary numbers. And then the major objective today is to talk about addition and subtraction of binary numbers. I want to believe that some of you have understanding about binary numbers. But for the sake of those that don't, binary numbers are basically numbers with base 2. They are basically numbers with base 2, two bases. And they are usually represented as ones and zeros. Nothing more, nothing less. You have the numbers represented as ones and zeros, and their bases are usually base 2. So when you hear binary numbers, just imagine zeros and ones with base 2. Okay? So having said that, we'll go on to the topic of the day, which has to do with the addition and subtraction of binary numbers. Now look at this illustration here, or this expression here. These are regular digits from 0 to 9. I hope you're seeing it. Regular digits, counting numbers from 0 to 9, and their binary equivalent. Okay, so when you have 0, the binary equivalent is expressed like this. So you have 1, the binary equivalent is expressed as this 001. For 2, it is 0010. For 3, it is 0011. 4, you have 0100. For 5, you have 0101. For 6, the binary equivalent is expressed as 0110. For 7, you have 0111. For 8, you have 1000. And 9, you have 1001. Now, in a bit to add binary numbers, with your understanding of their equivalent expressions, you'll be able to figure it out easily, as well as the subtraction. But let's start with the addition. Now, for example, we are asked to add, say, 0010 plus 0101, all to base 2. Remember, I said binary numbers are numbers with base 2. Okay? Now, looking at this, one might be wondering, what am I supposed to do? Or some might just go ahead and begin to add 0 plus 1, 1, 1 plus 0, 0, 1, 0 plus 1, 1. Then they end up having answer that looks like this. Say they arrange it, and then you have 0, 1, 0, 1. And then you say 0 plus 1, 1, 1 plus 0, 1, 0 plus 1, 1, then 0. This is wrong. It is not this way. So addition of binary is different from adding regular counting numbers. So in a bid to give you an easy way to understand it, there are several methods to add, but I'll show you one very quick way for time purpose. Okay, so the first thing you want to look at is, what is the equivalent digit for this one? I gave a table or an illustration before I started. If you look at this, you trace the one on the given chart. When you do that, 0010 here is 2. So 0010 on the table or on the chart is 2. Then 0101 here is 5. Okay? So this is 2 plus what? 5. Isn't it easy? It's quite easy. It's not difficult at all. Having done this, you can add straight. 2 plus 5 will give you 7. So to get your binary equivalent, you come back to the chart and get 7. Coincidentally, adding it straight gave the same answer. If you remember when I added it as the one I told you not to do, it gave the same answer. But to be on the safe side, I believe you would use the recommendation I gave. When you add this, you have 1, 1, 1, and 0. Coincidentally, 7 is also 1, 0, 1, 1, 1. This doesn't happen in all cases. Please take note. Okay? This doesn't happen in all cases where if you add straight, you will get your answer to that place. So just go straight, look for it on the chart, pick it out, and then add. Then your answer, trace it on the chart, and express it in binary form. Are we following? Let's get another example. You have 1, 0, 0, 0 plus 0, 1, 1, 0, all to base 2. All right? Now let's do this together. Let's look for this on the chart. You have 1, 0, 0, 0. That's 8. The digit equivalent of this binary is 8. For 0, 1, 1, 0, looking at it here, the equivalent is 6. Are we following? What you have here is what? 6. 8 plus 6, you have 14. Now, this might set some people into confusion and they'll be wondering, but there's no 14 on the chart given. I can further develop this to get to 14 because all these are about patterns. It's not just random numbers. There's a pattern to the way the binary equivalents are formed. Okay, so follow me. I stopped at 1, 0, 0, 1. The next is 1, 0, 1, 0. 11 will be 1, 1, 1, 0, 1, 1. 12 will be 1, 1, 0, 0. Okay, 13, you have 1, 1, 0, 1. 14, you have 1, 1, 1, 0. Are we following? And then 15, you have 1, 1, 1, 1. Maybe in subsequent classes, I'll tell you why it appears like it starts afresh at some point, where it goes back to 0 with one of the digits changing. That's a more advanced aspect of binary that I'll talk about subsequently. But for today, just stay with me. Okay, so based on the pattern you have on the board, I can now tell you the answer for 14 since I have covered it on the chart. Now, if you look at the chart, 14 is 1, 1, 1, 1, 1, 0 to base 2. Are we following? 1, 1, 1, 0 to base 2. Coincidentally, if you have added this straight, it will give you the same thing also. But I advise you don't always add straight because of the fact that you might run into some kind of difficulty. 0 plus 0 will give you 0. 0 plus 1 will give you 1. 1 plus 0, 1 plus 0. The answers are the same, right? But stay with me. Today it's about this method. Subsequently, I can introduce other methods, but just stay with me, okay? All right, so that's enough for addition. Let's go straight to subtraction of binaries. So that is 2. The same method, but this time we are subtracting. 1, 0, 0, 1 is 9, minus 0, 1, 1, 1 is 7. The answer is 2 with the natural numbers, but for binary, 2 equivalent is 0, 0, 1, 0. Okay, so here we go. Now, this is part of the reason why I said don't subtract or add straight. Assuming we're going to use straight subtraction to solve this problem, Let's see what we will get if it tallies with this. Okay, 1 minus 1 is 0. Now look at this, 0 and 1. Naturally, 0 is less than 1. So you tend to see people borrowing 1. From where? From the one that already exists. Okay, and then if you borrow 1, 1 plus 0 is 1. Then you borrow another 1 from here, it becomes 1. 1 minus 0, 1 minus 1 would have given you 0. The one you borrowed from here left this one as 0. But there's no other, there's a lot of confusion with straight subtraction. So just stay with me until I give you another method. So for today, it's about this method. All right? Let's take another example to round off. What's 110 on the chart? You have 14. What's 1101? You have 13. 14 minus 13 will give you 1. And 1 on the chart is 0, 0, 0, 1 to base 2. So class, this is the much we will do for today. And I pray and hope that you were following and were able to grasp the, the class. Okay, so you can use this chart for your own exercises in solving binary problems. So I'll quickly give you an assignment. Please endeavor to use the chart. Since there's a particular method I require of you, follow the method I taught, use the chart to solve the problem. Okay, so try your hands on this and we'll go over the work you've done in the next class. So till I come your way again, have a great day.